just like we did for multiplication, finally here we can do estimation and reasoning for division. So I would start with my estimate. For my purposes, please make sure that you show me what you are estimating each of your numbers as, your dividend and your divisor, and then also show me what answer you're getting. If I just round these to whole numbers, the nearest whole number, this would be 9 divided by, so the 1 rounded down, but the 7 rounds up, so 9 divided by 5. And that is, it's okay. Again, your estimate, whatever you choose to use, should be something that's easy to do in your head. So if you have trouble with 9 divided by 5, you might change it a little bit, right? You might see if, you can estimate it a little bit differently, to do something that's a little easier to do in your head. 9 divided by 5, it's not bad, right? So I know it's close to 2, and honestly, that's good enough. So if you just wrote something like that, said it's close to 2, that would work. If you'd rather go ahead and say, well, the reason I knew that was close to 2 is because 9's close to 10, right? So maybe that would be a better estimate, right? So either of these would be fine, right? The point is you're getting something close to 2. So you just pick something that's easy, right? And then I'm going to do the division. And you can do whatever division method you like. I'm just going to stick with a standard long division algorithm, but you can do, scaffolding or, box division, whatever method you like. And when I do this, I'm not going to have decimals in it at all, right? I'm going to take the decimals out because I don't need to worry about that, right? I'm going to do this as 913 divided by 47. And that's the process I'm going to go through here. And then I'll just worry about my decimal in the end. So 47 won't go into 9, but it will go into 91. I know, let's see, it'll go in once. Will it go in twice? I don't feel like it will, because I know 45 times 2 is 90, and this is a little more than that. So I feel like it's just going to go in once. So I'm going to put that above the 1. 1 times 47 is 47. And subtract that. So this would be 11 minus 7 is 4. And then I had to regroup from this. So that would be 4 as well. So yeah, I know that I picked correctly because I was able to subtract, right? I didn't get something bigger than 91. And then when I subtracted, I didn't get something bigger than 47, right? So I know I picked correctly. And then I'm going to bring down the rest and keep going. So let's see, I have to figure out how many times 47 goes into 443. That doesn't look very fun. Let's see. So I'm going to take a guess at this. So 47 is reasonably close to 50. If I did 50 times 9, that would be 450, right? Because 5 times 9 is 45. So I'm going to guess 9 here. But again, you're not expected to know this. Use something that erases, and whatever you pick, if it's not correct, it should point you towards what is correct. So 9 times 7 is 63. 9 times 4 is 36, plus the 6 that I regrouped would be 42. So then when I subtract, I get 20. So I actually did pick correctly. I know that because 423 was smaller than 443, and 20 is smaller than 47. So this is where I would stop if I were doing fractions, but since I'm doing decimals, I'm going to keep going. So technically I would put a decimal here, and I should technically bring that up to my answer. However, we're going to worry about decimals at the end. So in this case, I'm not going to worry about that, right? I'm just going to go ahead and attach my 0 and bring it down, and I'm just going to keep doing this, right? I'm going to keep attaching zeros and bringing it down until I get an answer, right? Until it repeats, or until it has a 0 remainder, or I may just decide to round it at some point, and that's okay too. So I would, if I were doing this for real, I would go ahead and bring my decimal up, but since I'm not going to worry about decimals to the end, I'm not going to worry about that. So let's see, 47 into 200. I just erased my regrouping from earlier so I don't get confused. 47 is close to 50. 50 would go into 204 times. So I'm going to try a 4. So let's see, 4 times 7 is 28. 4 times 4 is 16, plus 2 is 18. That looks good because 188 is not bigger than 200. Let's subtract and make sure that what I get isn't bigger than 47. So if I subtract here, I get 12. So that looks like a good choice. Let me erase my regrouping from earlier. Since my remainder is not 0 yet and I don't see anything repeating, I'm going to attach another 0 and bring it down. 47 will go into 120. I'm going to guess 2 times, maybe 3. Let's see if 2 works. 2 times 7 is 14. 2 times 4 is 8 plus 1 is 9. If I subtract, I get 26. So that worked because 94 was smaller than 120 and 26 is smaller than 47. I'm gonna just do this one more time, and then if this doesn't work, I'm gonna just round it. So bring down another 0, erase my regrouping. 47 into 260. So I'm gonna guess, so 50, again, 47 is close to 50, so I keep using that. 50 times 5 would be 250. That's pretty close. So let's see if that works. Let's try 5. 5 times 7 is 35. 5 times 4 is 20, plus 3 is 23. That looks good because it's smaller than 260. Let's subtract and make sure I don't get something bigger than 47. 7 minus 5 is 5. 5 minus 3 is 2. Yeah, that works. So technically I would keep going if it didn't let me round, but if it tells you to round, I'm just gonna go ahead and do that. So I'll stop here. At this point, I would not be able to necessarily decide where to round it to. I'm just gonna go ahead and write down my digits. So 19425, and that keeps going. And then remember, I have to decide where my decimal goes. So, maybe it's going to be 19,425, or maybe it's going to be 1,942.5, or maybe it's going to be 194 and some change, or maybe 19 and some change, or maybe 1 and some change, right? And so this is when I go back to my estimate and say, well, my estimate was that it was supposed to be close to 2. So where would that decimal make the most sense? It would make the most sense to put it behind the 1, right? Because 1.9, that's going to be the closest to 2. And then decide where you're going to round to. So let's say if I wanted to round this to the nearest thousandth, 10th, hundredths, and then the thousandth place, I would have to look behind that. The 5 would actually round that up. But this would be different depending on where they said to round to. If we had been asked to round to the nearest hundredth, then I would have actually said that this was 1 and 94 hundredths, right? If they had said round to the nearest tenth, I would just say 1 and 9 tenths. All right, so then let's do one more. So this is 86 hundredths is reasonably close to 1. Start with our estimate. And then this is close to 4. So 1 divided by 4. That one's not the easiest thing to do. Like, we're not getting a whole number, but it's not bad, right? So 1 divided by 4 is actually 1/4. And if you happen to know the decimal, a lot of people memorize that 1/4 is actually 0.25 or 25 hundredths. So that one's easy enough that you could get a decimal there and it would be okay. So I want some answer that's going to be reasonably close to 25 hundredths or 1/4. So then I'm going to go ahead and do the division. But when I set up my long division, I'm going to leave those decimals out entirely. So I'm going to do this as if it was 86 divided by 43. And that one's not bad at all. I can see that that's going to go in 2 times. 2 times 3 is 6, 2 times 4 is 8. So I get a remainder of 0. And so then I'm getting 2, but 2 isn't my answer, right? So 2 might have the decimal in front of it, or there might be a decimal and then a 0 in front of it, or it might be the decimals right behind the 2, or it could be the decimals right in front of the 2, or it could be a decimal and then a 0 and a 2. So again, you don't have to list these, but this is just kind of what I'm seeing in my head about where that decimal could go. And then I just pick the one that's closest to my estimate. So this was 0.25 or 25 hundredths. So the one that's closest to that would be the decimal right in front of the 2. So that's my answer, would be 2 tenths.